So what partial fractions is that it's asking you to decompose or break down a fraction. So trying to figure out what this would be, like pretend you have two fractions that you're adding together. What two fractions would you add together that would become this? But you can't just say, you can't just kind of give them the common denominator prior. You'd kind of be thinking something had a denominator of x plus 2, and I was adding it together with something that had a denominator of x minus 4. So what would those numerators be? I'm not going to use x and y because x already exists in this problem. I'll use a capital A and a capital B. Any thoughts? Any brainstorming we can think about? Let's do it this way. Let me give you a couple minutes to play around with this and try to figure out what A would have to be and what B would have to be, so that when you add these fractions together, which would require getting a common denominator, adding them together, so that this would pan out to be x plus 14 on the numerator. You do? Raise your hand if you think you got it. Like, raise your hand if you could tell me an answer right now. Adam and Josh. Well. Raise your hand if you think you're making good progress. You just need a little more time.
I got it, yeah.
Who thinks they're making good progress? No? Taylor? No? Raise your hand if you feel like you're completely clueless. Okay. Josh, what did you...
A is -2 and B is 3.
Adam?
I did it a little wrong.
How do you know?
Because I used x minus 4 twice. I just got confused. I tripped up.
Okay. Raise your hand if you think Josh...
I'm down to 3.
You like it? -2 and 3?
Yeah. You have to multiply. Don't you have to multiply x?
How many of you, raise your hand if you'd be shocked if I told you, not shocked, but impressed if I told you Josh was correct. Come on, if you're impressed.
I wouldn't,
You won't say you're impressed? I'm impressed. Come on, you guys are all sitting there going, I'm clueless, and he just knows the answer. Like, you're not impressed? I'm impressed.
Is it the
It is.
You mean surprise? Not like surprise.
I wouldn't be surprised. Josh's a smart kid. Impressed. I'm impressed. You should all be impressed if you were sitting there telling me that you were clueless. So, Josh, I want you
Go to the board and
to tell them all what you did.
Alright, well, let's get a common denominator, so A has to be multiplied by x minus 4.
Okay, so in order for this all to add up to get this, you would need a common denominator. So this would need an x minus 4. And so x minus 4 over x minus 4. And this one would need an x plus 2 over x plus 2. So he has his common denominator all the way across, so he can forget about it, forget about it, forget about it. And so this is what he's left with. Okay, so then what'd you do?
1.
Did you do anything here first? Did you distribute your A?
No,
So out of pure luck.
No, I don't think it's pure. It's good gut. It's good gut instinct, I think is what it is. And there is something to be said for that in math. Like, I don't know, you got a good feeling and you can't really quantify or explain it, but you just kind of know it. That exists. I know it does. So I don't think he got lucky. I think he's got good math instincts. But what to kind of document what's actually happening here, you would distribute, and then normally you would combine like terms. So your x's would get combined with x's, so that would be ax plus bx. I'm just rearranging here. And then your constants would be combined minus 4a plus 2b. So at the end of the day, this is supposed to equal x plus 14. So the coefficient on your x is supposed to be 1. So when you combine these, a plus b is supposed to equal 1. And then these are your constants. They're supposed to combine to be 14. So negative 4a plus 2b is supposed to equal 14. You did say something about it's supposed to be 1. Is that what you meant? Okay. And then this is just a system of equations with just 2 variables. So if I use elimination and I use a multiplier of 4, that's going to line it up under here. That's going to make 4a plus 4b equals 4. So here are my 2 equations. Should I add or subtract? Opposite signs add. So that'll give me 6b equals 18 and b equals 3. And then once you know b equals 3, a plus 3 equals 1, a equals negative 2. And so the partial fraction decomposition of this is negative 2 over x plus 2 plus 3 over x minus 4. And you've come up with the partial fractions that would add together to make that sum. Jalen. Here. Here. Okay, so I rearranged this as if I was going to be able, because normally a and b are just some numbers. So if it was 5x plus 2x, I would be able to just say, oh, 7x, right? So I'm just sort of rearranging to get here, combining my x terms. Now when my x terms combine, I need it to equal 1x. So the coefficients a plus b have to combine to be 1. And that's where the equation a plus b has to equal 1 is coming from. Does that answer your question? Elimination? So you know where I got this equation and this equation from. So then that's my 2 equations, 2 variables. I just decided to get my a's to be the same coefficient, so that's why I multiplied by 4. I used a multiplier. So if I kind of organized it differently, there's one equation of my system, and here's the second equation of my system. I just decided, now someone else could decide to get the b's to have the same coefficient, and they could use a multiplier of 2. I decided to get the a's to have the same coefficient, so I did a multiplier of 4. So that became 4a plus 4b equals 4. This one stayed the same, negative 4a plus 2b equals 14, and then I added them. Any other questions? Okay. So today we're only doing linear factors. I put that up underneath the title. X plus 2 is a linear factor in your denominator. X minus 4 is a linear factor. In the second example, though, I still have all linear factors. I just have 3 of them. One factor is x, A second factor is x minus 3, and a third factor is another x minus 3. So this is kind of going to teach us what to do when one of your linear factors happens more than once, is a double factor, or has a degree of 2, whatever you want to say. When you break this one up into partial fractions, you have 3 factors, you're going to have 3 partial fractions. So one of them is going to be a over x. A second one is going to be over x minus 3. The third one, though, is a little bit different because when you have a degree on one of your factors, your third factor is just going to increase that to x minus 3 squared. And I'll outline how that works on the back. But you don't just do a third c over x minus 3. Okay? You have to do the x minus 3 squared. So again here, I could go through and get a common denominator all the way across and then cancel the denominators, but I'm going to show you a different way of doing it as well. I'm going to do it the clearing fractions way. So the least common denominator is always going to be this one. So if I multiply both sides by x times x minus 3 squared, that's obviously going to clear the denominator on the left. And then when I start to distribute it on the right, it's going to clear a different thing in each individual fraction. So when I first distribute it to the a, the x's just cancel, and I have a times x minus 3 squared. When I distribute it to the b, one of the x minus 3's cancels, leaving just x and one of the x minus 3's. And when I distribute it to the c, the x minus 3 squareds cancel, and I just have plus cx. And all of this is supposed to equal x minus 18. So I've got some cleanup to do over here. This is a times x squared minus 6x plus 9 when you square that out. And then you should distribute your a, so you're going to get ax squared minus 6ax plus 9a. In my middle term, I'm going to have to distribute my bx, so that's going to give me plus bx squared minus 3bx. And then in my third term, I don't have anything to do, it's just plus cx. Then comes the rearranging. So getting all your x squareds together. So I have an ax squared plus a bx squared. That handles those two terms. Then getting your x terms together. I have 3 of those. I have negative 6ax minus 3bx plus cx. That takes care of those 3 terms. I like to cross them out once I account for them so I don't accidentally miss something. And then I have just one constant plus 9a. So on the left-hand side, how many x squareds am I supposed to have? Technically 0 x squareds. Plus how many x's? 1x minus 18. And this will build your system for you. So your x squareds coefficients are supposed to combine to be 0. So a plus b is supposed to equal 0. Your x terms are supposed to combine to be 1. Raise your hand if you can give me that equation with a's, b's, and c's. Liam.
Negative 6a minus 3b plus c.
Has to equal?
1.
Good. That just takes the x coefficients, the negative 6a, the negative 3b, and the c, combines them and says it's supposed to equal 1. And then 9a is supposed to equal negative 18. So, obviously not a traditional 3-variable system. It's much easier than that because immediately the first variable we should find the value for is a. Take this, divide by 9, Your A is negative 2. Once you know A, and you've used that equation, which one should you go back and find? B. So negative 2 plus B equals 0, which means B equals 2. And then once you know A and B, we can go back to the third equation and do negative 6 times negative 2 minus 3 times 2 plus the C value equals 1, and solve for C. So this will be a positive 12, which I should subtract 12 from both sides. This will be a minus 6, so I'll have to add 6 to both sides. So that'll be gone, and C equals negative 5. So your partial fraction decomposition says that this original fraction that we were trying to decompose and break apart does now break apart to being negative 2 over x plus the b, which is 2 over x minus 3, plus the c. I'm not going to do plus negative 5. I'll just do minus 5 over x minus 3 squared. And we've decomposed that single fraction into 3 parts. So if you put this in front of an Algebra 2 kid and said, simplify, they would give this denominator an x minus 3 squared, they would give this denominator an x and an x minus 3, and they would give this denominator just an x, and then they would be able to simplify those numerators, add their fractions together, and they should get that. Good? Okay, so now on the back, I didn't want to start with this and scare you off, but here's really the symbolic version of each case, okay, where you have some polynomial on top and some polynomial on the denominator. The denominator polynomial should factor into different pieces, okay, and then to set up your partial fraction decomposition, each linear factor gets its own denominator. That's like the first example when we had no repeats. The second case is when your polynomial in the denominator factors into a linear factor to some power. So the power we worked with was a power of 2. So we had just an ax plus b, and then the next one was ax plus b squared. But if something had a degree of 5, it was a linear factor with a degree of 5, you would need 5 different fractions to account for that. One with the denominator just being raised to the first power, one being raised to the second, the next one being raised to the third, the next one being raised to the fourth, and so on. And on the front side, I used a, b, and c. Here, I could have used a, b, and c all the way to z, but I just used a sub 1 plus a sub 2, just really a different letter to solve for up top. Okay? So the way that, unfortunately, you have to write that to be very generic, to be a rule, is kind of more confusing than it's worth. But I did want to show that to you, and I also didn't want to start by showing that to you because you would have thought this was the hardest thing on the planet. And it's not that bad. So on the independent practice here, these are slightly different than the front side because our denominators aren't factored yet, so that should always be the first thing you do. And this denominator is going to factor into x plus 4 and x minus 3. So take a minute and try to set up now the partial fraction decomposition with your a's and b's and c's as your numerators. Zach, did you split it up? Yeah. What did you split it up into? Perfect. Now, raise your hand if you like there's two methods that I've shown you. I've shown you the get the common denominator method or the clearing fractions method. Raise your hand if you like the get the common denominator method better. 1, 2, 3, 4, 5, 6, 7, 8-ish of you. Raise your hand if you like the clearing fractions method better. Oh, okay. So then get your common denominator all the way across. This one needs an x minus 3. This one needs an x minus 3. This needs an x plus 4 over x plus 4. So then we can drop, drop, drop. 5x minus 1 equals ax minus 3a plus bx plus 4b. Take a minute to rearrange and come up with your system. Nathan Z, what's your system? Y minus bx plus bx. So he's got the ax plus the bx has to equal 5x. So what's the equation with just a's and b's and without the x? Right, a plus b has to equal 5. And the other equation, Nathan? Perfect. Any questions on that? Okay, so I'm going to solve by elimination. So I'm just going to throw a 3 in each of those. That'll make it a 15. That saved me some writing. Add. I'm going to get 7b equals 14. b equals 2. If I had kept it, a plus b equals 5, which is what it was, I can do a plus 2 equals 5, so a equals 3. So your partial fraction decomposition of that original fraction is 3 over x plus 4 plus 2 over x minus 3. Yes. Which is exactly, no, it doesn't matter, which is exactly why, though, this is not our final answer. A equals 3 and b equals 2 for the way we set it up. You set it up differently, so your b equaled 3 and your a equaled 2, correct? But when we write this, we should be writing the same thing. Right, because you had them flip-flop, so the double flip-flop kind of worked itself out. So that's why that's our final answer, and that's not your final answer. Does that make sense? Okay. All right. Anything else? Let's jump over here. How do we factor that denominator first? Take out an x. And then what do we do to that denominator? Okay, so what does this trinomial become? Okay, x minus 1 times x minus 1, which we're going to write as x minus 1 squared. Okay, and the fact that we have kind of a double factor, think about your asymptotes that are double asymptotes. When we did rationals, remember if we had an asymptote at 1 here, and it had a power of 2, the behavior on either side would be the same. Okay, anytime there's a double factor, double root, double asymptote, something kind of tricky happens. And here, that's just when we set this up, x plus 2 over this. Who thinks they can give me the setup? Go ahead, Stephen. Perfect. and then we would go from there. Let's go up. Let's just set up the last one, and then I'll give you the remaining time to finish them through. So on our yes. I think to fully wrap your head around why I would almost have to like tell you, okay, try to figure it out your own way. And almost we'd have to see how that fails to wrap our head around why this is the appropriate way, which we can try in a minute. Let's set up the next one, and we'll come back and we'll spend the rest of our time failing at what our other option would be to kind of wrap our head around why whoever figured this out realized this is the way to do it. So let's just do this one first, which has, it already factored in the denominator, but it's a degree of 4. So this is actually going to have 4 parts. A over an x plus 1 plus b over x plus 1 squared plus c over x plus 1 cubed plus d over x plus 1 to the 4th. Now, we're doing that, to Stephen's point, because we were told to. That's the rule. The question is why. Now, would we be able to go from here? This one's going to be quite ugly. Mainly because this needs what? Right, and that's going to be a disaster. This one is going to need what? Squared. This one needs just an x plus 1, and this one needs nothing. So we would drop all this. And so this part's going to be a little bit of a headache. I wish I'd already done this because I would jump you forward without doing it. Let's do the b first. The b is going to be times x squared plus 2x plus 1. The c is going to just be cx plus c plus the d. Now we just need to come up with what x plus 1 cubed is, which here is x plus 1 squared, times another x plus 1 is going to be x cubed plus 2x squared plus x squared plus 2x plus 1. So that's all in all going to be x cubed plus 3x squared plus 3x plus 1. So that is x plus 1 cubed. We just need to distribute an a to it. So that's going to be ax cubed plus 3ax squared plus 3ax plus a. We're going to have to distribute our b. So ax cubed plus 3ax squared plus 3ax plus a. Distribute your b. And here you're going to see why I cross things out as I account for them, because I don't want to forget anything. So my x cubed terms are supposed to add up to what? How many x cubes do I have? 0. So that's kind of nice, because if ax cubed is supposed to equal 0x cubed, then that gives us that a equals 0. What are my x squared terms supposed to add up to? So 3a plus b is supposed to equal 2x squared, so 2. Well, I already know a is 0, so what's b? 2. My x terms, so that's a 3a plus a 2b plus a c, are supposed to add up to what? 8. So that's 0 plus 4 plus c has to equal 8. So what does c equal? 4. That's all my x terms. And then my constants, a plus b plus c plus d, has to add up to the 3. So that's 0 plus 2 plus 4 plus D equals 3. Subtract 6 from both sides. D equals negative 3. And so to write your final answer, again, this is not your final answer. You would have to write 0 over x plus 1, which you could just not write, right? Because that's just 0. 2 over x plus 1 squared plus 4 over x plus 1 cubed plus negative 3 over x plus 1 to the 4th. Oh, Stephen, we don't have time.